Hello, welcome to the world of aviation, understanding air navigation. And in this first YouTube lecture, I am going to concentrate on how to pilot a general aviation aircraft from point A to point B safely. Allow me to give a very special welcome to a very special group of people. These are the aspiring young aviators or enthusiasts. So today, you are embarking on a unique journey of exploration through the fascinating realm of air navigation. And I invite you to buckle up as we take flight on an enlightening adventure designed to broaden your horizon and spark your passion for the skies. In this YouTube lecture, I intend to guide you through the foundational landscape of air navigation. This isn't your typical academic lecture filled with dry theories and technical jargon. So relax. Here, my aim is to ignite your interest, enthusiasm, and to fill your mind with practical insights. And I do hope that by the end of this presentation, you would have gained a deeper appreciation and understanding for the fundamental requirements of piloting. You learn about essential tools and strategies that every successful pilot should have. Our goal is to demystify the navigational processes and allow you to envision your own future in aviation. And for all the young dreamers out there, I want to encourage you to follow your passion, seek your dreams, and remember that every great pilot started with one simple step: a desire to fly. So, welcome. Many people ask, how does one fly an aircraft from, say, point A to point B? What does a pilot do? What does a pilot require? So how does a pilot fly an aircraft? This is the subject of this lecture. First of all, let us begin by defining what air navigation is. Air navigation simply is the art of flying an aircraft from point A to point B, and you do this without getting lost, breaking the laws applying to aircraft, or endangering the safety of those on board, other aircrafts, or on ground. It is important to know that there are basically two main ways of flying an aircraft from point A to point B safely. And this is based on the rules and laws of flying. So the first set of rules for flying an aircraft from point A to B is the visual flight rules, which are commonly known as VFR. The second set of rules is known as instrument flight rules, which are commonly known as IFR in the aviation language. So what is VFR? Now, in the case of VFR, the pilot will normally navigate using visual awareness. That means just understanding where he is with respect to ground or the terrain he is flying above. And will take into consideration his speed, flight direction, familiar terrain, wind and weather. And he does this with the help of the following: a predetermined flight path, which he has decided before flying, a compass, and a map. Once in the air, he will strictly stick to his flight plan, but he will be revising it as he flies, depending on several factors that we shall see later in this lecture. So this mode of piloting is known as dead reckoning. In summary, a VFR pilot will largely navigate using dead reckoning combined with visual observations, or known as pilotage, with reference to appropriate maps. This may be supplemented using radio navigation aids. So how does a VFR pilot plan his route or his trip? The first step in navigation or in VFR or in visual navigation is deciding where one wishes to fly. And to assist in this, one needs to have an aeronautical chart for the area they are flying in. And the chart is normally published by the local civil aviation authorities. In this map, you'll always find controlled airspace, radio navigation aids, airfields and hazards such as mountains, tall radio mast, etc. It will also include sufficient ground details such as towns, roads, wooded areas, which will assist in aiding visual navigation. One will also need to have a copy of notices to airmen, commonly known as NOTAM. And these are very important because they normally contain the latest information concerning the airspace you're going to fly into. So the pilot will initially choose a route, and in doing so, avoiding all controlled airspace and restricted areas. You'll also avoid danger areas. So when you talk of controlled airspace or restricted areas, these are areas like State House or military bases. Now the pilot will then plot his preferred route on the map, which is called a track, and he must keep to it as accurate as possible. He will calculate the heading for each leg of the trip before departure, using the reported wind directions and speeds supplied by the meteorological authorities for the purpose. So once in flight, the aircraft will experience the effect of wind, which will tend to alter the heading of the track. So the pilot must therefore continually adjust the heading of each track to compensate for the wind. So the flight time will depend on both the desired cruising speeds of the aircraft and the wind. So you'll find that a tailwind will normally shorten the flight time because it will be pushing the aircraft towards the direction it is moving. Whereas a headwind will always increase them because it will always be trying to resist the aircraft in that direction. The pilot uses a very important tool called the E6B, which is a slide rule, and it can be mechanical or electronic, to determine aircraft ground speed, time, airspeed, and distance calculations, fuel burn, time and route, and density altitude. The same tool is also used to convert knots into miles per hour and vice versa. It will calculate true speed to calibrated airspeed and vice versa. Celsius to Fahrenheit, and it will calculate wind correction angles. So even as he plots, the pilots must be aware of the point of no return. This is a very important point because the point of no return is a point on a flight at which a plane has just enough fuel to return to the airfield should you want to go back from which it departed. Beyond this point, that option is closed and the plane must proceed to the next destination or the nearest destination. Also, the pilot uses a magnetic compass to reduce magnetic variation between the magnetic north and the true north. We shall be looking at this in more details in other lectures. So once the pilot has calculated the required headings, the next step is to calculate the flight times for each leg. This is necessary to perform accurate dead reckoning. The pilot also needs to take into account the initial airspeed during the climb to calculate the time to top of climb. It is also helpful to calculate the top of descent or the point at which the pilot would plan to commence the descent for landing. These are very important points also in piloting. At the same time, the pilot needs to know the areas he will be flying over. You will also need to know which air traffic control units or ATCs to contact, the appropriate frequencies that he needs to have on board to be able to communicate to the pilots or to the air traffic controller, and all the visual reporting points and so on. Another important thing the pilot needs to note is the pressure setting region, so that the pilot can ask for the QNH of those regions. Finally, the pilot should have a backup plan just in case the route cannot be flown due to some unexpected reasons like weather, bad condition, etc. So what happens once in flight? So once the pilot is airborne, he must take pain to stick to the plan. Otherwise, getting lost is too easy. And this is especially true if flying over featureless terrain, that is flat terrain where there is no mountain, no river. It's important to stick to your plan. This means that the pilot must stick to the calculated headings, heights, and speeds as accurate as possible. So the visual pilot must constantly compare the ground with the map to ensure that the track is being followed. If the wind is different from that expected, the pilot must adjust heading accordingly. But this is not done by guesswork, but by mental calculation. And a good pilot will become adept at applying a variety of techniques to stay on the track. So, for example, a 2-degree error at halfway stage can be corrected by adjusting heading by 4 degrees the other way to arrive in position at the end of the leg. Now, although the compass is the primary instrument used to determine one's heading, it is not stable. So pilots will usually prefer to use the directional indicator if it is installed in the aircraft, that is the DI. This is a gyroscopically driven device that is much more stable than a compass. The compass reading will be used to correct for any drift of the DI periodically. The compass itself will only show a steady reading when the aircraft has been in a straight and level flight long enough to allow it to settle. Now, should a pilot be unable to complete a leg, for example, because of bad weather, or the visibility falls beyond the minima permitted by the pilot's license, then the pilot must divert to another route. Since this an unplanned leg, since this is an unplanned leg, the pilot must be able to mentally calculate suitable headings to give the desired new track. Let us now look at IFR, or Instrument Flying Rules Planning. So how does an IFR pilot plan his work? In the IFR case, the pilot will navigate exclusively using instruments or onboard instruments and radio navigation aids such as beacons which are on the ground, or as directed under radar control by air traffic control. So he must make use of what we call special charts that show IFR routes from beacon to beacon with the lowest safe altitude, or LSALT, bearing in both direction and distance marked for each route. So now, on board fitted electronic instruments for navigation, the pilot also needs to look at the weather and minimum specification for landing at the destination airport and the alternate requirements. The IFR pilot must also comply with all rules, including their legal ability to use a particular instrument approach. So when a pilot wants to fly IFR, for each instrument that he wants to use, which is on his dashboard, he needs to be licensed to use it. And therefore, we are talking about the pilot must also comply with all the rules, including their legal ability to use a particular instrument approach, depending on how recently they last performed one. So normally the IFR aircraft will be fitted with a variety of radio navigation aids. on board, such as automatic direction finder or ADF, very high frequency omnidirectional range VOR, and in modern or in most cases you will find that the VOR is collocated with the DME or the distant measuring equipment so that you can calculate both the direction and the distance from the equipment. We'll also onboard fitted is a global positioning system, that's the GPS. ILS in some aircrafts to be able to make a landing even in harsh weather. Automatic dependent surveillance broadcast ADSB. This is some of the modern technologies coming on board the aircrafts. Automatic dependent surveillance contract also coming new. These are some of the new technologies already finding their ways to the dashboard of the aircraft. And the operation of some of this equipment mentioned will be explained in detail in other videos. So here is just to give you a feel of what onboard equipments look like or are. Finally, an aircraft may be supervised from the ground using radar. So an air traffic radar controller can also feed information to the pilot, the IFR pilot, to help him establish his position. Or he can actually tell the pilot the position of the aircraft, depending on the level of air traffic control service the pilot is receiving. Thank you, and let us meet at the next lecture. Goodbye.